So a reminder, what we did yesterday. Yesterday we were looking at the Millikan problems, where the weight force and the electric force were equal, right? It was suspended in air, and Millikan used that idea. He could figure out the mass, which you guys ended up using volume and density, right? He could figure out the mass, multiply by gravity, that gave him the weight force, that gave him the electric force, Q times E. He knew the electric field strength, so we were solving for Q, right? That's what we were doing yesterday. Okay, so today we're going to take it a little bit of a step further, and instead of these forces being balanced, one's going to be bigger than the other. So what's that going to do to the drop, I guess? What's it going to do to the drop? It's not going to be balanced anymore, is it? It's not going to be percent. If the electric force, the one on top, is bigger, then it's going to go up. In fact, it's going to accelerate up. And if it's the other way, if the weight force is bigger, well, then it's going to go. I don't know if I can do that. The weight force is bigger, then it's going to accelerate down, right? What's the fastest possible acceleration down that it could have? Negative 9.8, right to our code. So if you get a value that's more than minus 9.8, you know you've done something wrong, right? Or it's not happening on Earth. Yeah. Okay. So in other words, we've got a net force. So I've got 3 sample problems that go along with that. So can we do that? You've got this one here, right? Okay, so I got 3 for you to do, and then I'm going to give you some time to work, because it's high time that you sort of have some practice time. So we got a charge here, or sorry, we got a mass, a 1.0 times 10 to the minus 4 kilogram charge. That's the mass. Charge of 3.2 times 10 to the minus 19 coulombs. That's the Q. Dropped into an electric field. The plates are 1.5 centimeters apart. Oh, what's that? I guess that's distance, right? The electric field strength is 1 times 10 to the minus 10 to the 15. That's the E value. Determine the net force on the object. So they're not asking for the charge, they're asking for the net force. Let's draw a little picture. So we got weight force down, and we're going to have electric force up. Now we don't know which one's bigger, do we? So we can't really accurately draw a picture yet. It's just sort of a sketch. One of those is bigger. Well, I guess to find the net force, we're going to have to find those 2 individual forces, right? Well, let's start with the easy one, which is Fw equals mg. So that's going to be 1.0 times 10 to the minus 4. And the g value is going to be minus 9.8. Nine point eight times 10 to the minus 4, right? Should be able to do that in my head. Now, is that important that it's negative? It's extra important because one is down and one is up, right? We've got to make sure that the signs are opposite. So yes, I like to think that I left that off for a reason to point it out, but I just forgot. But it worked out nice. So yes, it is negative. Can we find the Fe going up? To find the Fe, we're going to need to know the Q and E. We got them both, don't we? Right? I like to write, the formula is E equals F over Q, but in these kind of problems, I know that it's going to be F is equal to Q times E. I kind of like just writing Fe is equal to Q times E. It's not really a new formula, it's just this one rearranged, right? That's all it is. Right? Multiply both sides by Q, that's all it is. So the Q value here is how much? 3.2 times 10 to the minus 19. The E value is, here's the E value, 1.0 times 10 to the 15. I'm right out of space. Would you wish you had this ability on your paper? Okay, so I get 3.2 times 10 to the minus 4. Now, most of the time, those exponents are going to be the same number. Okay, you see how I've got minus 4 and minus 4? Most of the time, they're going to be the same. They might be off by 1, like 1 might be minus 4, 1 might be minus 3. They have to be sort of in the same general ballpark, the same sort of general value. Because if this was like 9.8 times 10 to the 6, and this was 3.2 times 10 to the minus 4, well, that 1 times 10 to the 6 is going to be ginormous compared to this one, and this one's going to have no effect. So they usually should be sort of kind of relative to each other, about the same size. Does that make sense what I'm saying? Okay. One is positive, one is negative. Determine the net force. So the net force is simply adding them together. Net force means add up all the forces that make that. Most people like the positive in front, but it doesn't really matter. So mine 9.8 times 10 to the minus 4 plus 3.2 times 10 to the minus 4. You should get minus 6.6 times 10 to the minus 4, and that would be newtons. Okay, so all we did there was we found those two individual forces, Fw, Fe, we add them together. Determine the net force on the object. We solved the problem.
So, yeah. So, like, times 10 to the minus 4 and times 10 to the minus 4 is the same. When I just do it, it's 9.8 plus 3.3.
Yep, and then you just add you still have to add the times 10 to the minus 4.
Yeah.
Yep. Notice one other thing here too. Did we use that 1.5 centimeters? No. They threw that in as a distractor. Okay? And it happens from time to time, so don't freak out if you've got a leftover part. That make sense? Am I good? Lane, yeah? Okay. Do you want to try this one? We're not ready for that. Not yet. So he says no way. 4.5 times 10 to the minus 6 kilogram charge of 9.2 times 10 to the minus 15 is dropped into electric field. The electric field strength is that number. Determine the net acceleration. How fast is it traveling after 1.5 seconds? And how far will it have fallen in this time? Well, this is a bit of a review. The second part of it. These are getting bigger and bigger, aren't they? We have the mass. It's kilograms. This is coulombs, so that is charge. Dropped into electric field. The electric field strength is 3.2. That is our E value. Determine the net acceleration of the object. We're looking for A. How fast it's traveling after 1.5 seconds. That's our time. How far we're solving for D there. Lots of things. The first step is to find the net acceleration. Well, if we go back to this one problem here, how would I find the acceleration here? Like, what would be the next step, the next formula? I'd go F net equals m times a, right? I know the F net, it's that value there. I know the mass, I can find the a. So basically, we're going to do this, except we're going to add one more step at the end, and then we're going to do those other ones. I don't think we need to draw it. Let's go Fw is equal to mg. 4.5 times 10 to the minus 6 times minus 9.8. Oops. Minus 4.41 times 10 to the minus 5. Solve for the FE. It's equal to Q times E. The Q is this number here. 9.2 times 10 to the minus 15. E value, this one here, field strength, 3.2 times 10 to the positive 9. Be careful with positive and negatives on those exponents because the difference between minus 15 and positive 15 is huge. 9.2 exponent 15 times 3.2 exponent 9. 3.22 times 10 to the minus 5. And again, those exponents are equal, so that's good. The FW is negative, the FE is positive. Take your time here, just make sure everything's good. Solve for F net. Let's throw the FE out front. Does it matter what order you add these? No. People don't like the negative out front. So 3.22 times 10 to the minus 5. Oh, that's plus. FW plus a minus 4.41 times 10 to the minus 5. Hey, did I screw up?
I think you may have got the wrong answer for the FE equals.
Right here?
Yeah.
Okay. What do you think I did wrong, do you know?
I don't know what's wrong. I wrote it 1.9.
Okay. Oh yeah, so did I. Okay, thanks, man. 2.94. So what would happen if you made that mistake in this question, you think? If I'm from a marking standpoint. And you know what? If you had everything all beautiful, I might even be convinced to give you full marks. Right? I mean, clearly you know what you're doing. You just probably mistyped. Maybe instead of 9.2, I typed 9.6. I don't know what I did there. Right? Okay? If you showed all your work and it's all beautiful and you've convinced me you know what you're doing, if I'm in a good mood, maybe the Leafs won that night, might get full marks. Yeah, so the chances are slim then, I guess, right? Good point, Jason. Or if you make smart ass comments in class too, right, I guess? Same idea.
Whatever.
See, the Raptors lost to the Sixers last night? Jeez, how does that happen? Actually, the Sixers are a 500 team this year. Yeah. And beat the Cavaliers by a bundle. Okay, this calculator sucks. Well, here. Not enough light in here for my solar one. $1.47 times 10 to the minus 5, is that what you get? And it's minus 1.47 times 10 to the minus 5, right? Okay, so that's the net force, but we got to find the acceleration. So if that net force is negative, that means it's going to go which way? It's going to be going down, right? It's going to be going down. So the acceleration is going to be F net is equal to ma. Here's where that acceleration is going to have to. It's going to have to be less than 9.8, right? It's going to have to be. Mass is 4.5 times 10 to the minus 6, and I'm squeezing. .3 meters per second squared. Okay, so there'll be 4 steps, 4 marks for that. But it also asks how fast is it traveling after 1.5 seconds and how far will it have fallen in that time. This is basically, now we're into gravitational fields here. We're into a review of gravitational fields. That's our acceleration. How fast is it traveling after 1.5, after given our time? So now we're going to have to pull out our old friend A equals delta V over delta T. Good little review here prior to the exam. The acceleration is that should be negative. Minus 3.3 is equal to delta V over our time, which was it 1.5? So take that number, multiply by 1.5. I didn't have to clear it, it was just in my calculator. I get minus 4.9. That would be the change in the velocity. Therefore, the final velocity, because it's at rest, minus 4.9 meters per second. Lots of steps here. And now we got to find out how far it will have fallen. Well, the only formula that's got distance in it is the one that looks like this, V bar, right? We don't have V bar. We got to find it. Holy. Lots of work. 0 plus that minus 4.9 divided by 2. Still on my calculator, divide by 2, so minus 2.45. And now we can finally do the last bit. Minus 3.7. So minus 3.7 meters. Whew. Ready to see an answer? Was it hard, Colby? Did you get started on it?
Yeah, I got an answer.
Okay, that's good. This one's kind of, everything's flipped around backwards, isn't it? Right? Because now we are given the acceleration. So rather than finding it, we got to work our way backwards. He determined the mass of the drop to be 5.3. The electric field strength was 8.28. What charge were on the drop and how many elementary charges in it? This is actually what Millikan did. These are the steps. He found, it wasn't so much the suspended thing, it was he would actually measure the terminal velocity. He would find, it's kind of what he did here, right? But we're working backwards. Okay, so anyways, we've got an acceleration and we've got a mass. So with an acceleration and a mass, we can find a F net. Right? Is that the first thing you did? There might be a few steps that could be in a different order here. So we're going to find the F net. I might need that back, yeah. (5.3 times 10 to the minus 6 times the acceleration is minus 2.3. Is the fact that it's negative important?
Yeah.
For sure. That means it's going down. 5.3, it's going at 6 negative times 9.8 negative. 5.19. 5.19 times 10 to the minus 5, right?
No.
No?
We put,
Oh, did I? How'd you know that?
you said no. Because that's the FW.
Oh, I said it.
That's what that.
Oh, okay. I guess when I did the FW over here and I got the same number, I would have figured it out, eh? Holy, call Doug Zuina. I made 2 mistakes in 1 period. $1.22 times 10 to the minus 5. Am I good now? Now, this one is negative, and so is that one, isn't it, right? Am I right? Okay, now that I've got FNet and FW, I can find FE, can't I, right? Should I draw my little picture here now? At least you should have it in your head, right? So FNet is FE plus FW. The FNet is minus 1.22 times 10 to the minus 5. The FE is what we're solving for. And the FW is minus 5.19 times 10 to the minus 5, giving us an electric force FE of 3.97?
Yeah.
That rings a bit of a bell from previous years. 3.97 times 10 to the minus 5. But we want to know what the charge is, right? In elementary charge. Well, let's get it in coulombs first. So, E equals F over Q. The E value, 8.28 times 10 to the 13. The F value is this number. Now, should that one be positive? How come, Mallory? Because the other one's negative, so the FE has to be up. It's got to be positive, right? So F is 3.97 times 10 to the minus 5. We're going to solve for Q. We're going to switch them. 3.97 times 10 to the minus 5 divided by 8.28 times 10 to the 13. Excuse me. What's that number? You know you're old when you throw your back out sneezing. That's what you were thinking, wasn't it? You're so rude, Lane. We had to cancel Christmas because I couldn't go anywhere. 4.8 times 10 to the minus 19. Did you get that? That is in coulombs. She likes that story. But I got to do it in Elches, right? So how do I do that? Yep, last step. 4.8 times 10 to the minus 19. Divide by our good friend 1.6 times 10 to the minus 19. You're going to get? Did you get 4? No? Is it not 4? Oh, no, it's not 4. It's 3. It's 3, right?
Yeah.
Now, is that going to be a positive 3 or a negative 3? Do we know what the charge is, positive or negative? We don't know what the charge is, whether it's positive or negative, do we? I haven't mentioned this yet. Well, maybe I did. Like, if the upper plate is positive, that makes the bottom plates negative. So if it's going up, what does the charge have to be, positive or negative? How come, Jason? Because it's got to be attracted to the top one, right? So if it's negative, that means that it has actually 3 extra electrons, an excess of electrons, right? If it's negative, it's got more electrons than protons. I know that there's a question somewhere in your future that says, does it have extra electrons or does it have a lack of electrons? If it's negative, it has extra.
So you divide by 1.6 to know if it has extra electrons?
No, to find out how many elementary charges it is. But if I said the top plate is positive, then the charge has to be negative, right? If it was the other way around, right? Like if the top plate was negative, then the charge itself, then the charge itself would have to be positive, right? It's got to be attracted to that top one, doesn't it? Right? Yeah. So you have to know what the charge on the plates are. Okay, I kind of lied a little bit. I said I wasn't going to talk much today. I did a lot of talking. Okay? I'm going to give you some time to work. I realize it's not a whole lot of time. These ones here are like this style. If you didn't really finish enough yesterday, take some time on that. I'm going to give you today, I'm going to give you tomorrow to do some work on these, because I really think we need to practice that. Okay? I will hand out the pre-test tomorrow, so I think I'll hold off on it. Okay? Spend some time, do some practice, get good at it. Okay.